Hello. Today we're going to be interpreting the unit rate as slope. Rate is a comparison of two quantities that have different units, such as miles and hours. A unit rate is a rate in which the second quantity in the comparison is 1 unit. Okay? So, like if I say miles per hour, if I say 5 miles per hour, the hour is the 1 in that case. A storm is raging on Misty Mountain. The graph shows the constant rate of change of the snow level on the mountain. And so what they've done is they've drawn this graph. They kept track of the time in hours and the snowfall in inches. They want us to find the slope of the graph using the points 1, 2, and 5, 10, which can be found on this line. So at 1, 2, it's here, and at 5, 10, it is here. And we can find that the slope because it's the same as our constant rate of change. And if we use the formula that we learned in our last lesson, we can do the change in y over the change in x to find our slope, which is also the same as our rate of change. So in this case, my y2 would be 10, my y1 would be 2. So 10 minus 2. x2 is 5, x1 is 1, so then we'll have 5 minus 1. 10 minus 2 is 8, and 5 minus 1 is 4. I can simplify that by dividing both by 4 and get 2 over 1. And I'm going to leave it in this ratio. So they want to know what the unit rate of snowfall in per hour. Well, these are the hours and these are the inches. So it was 2 inches per hour. So 2 inches per hour. We can compare the slope of the graph and the unit rate of the change in the snow level and see what we notice. So when I'm looking at this, I also notice it crosses the line here. So I could go up and then across, up and across. Or I can see that every 2 is crossing. So it's going up 2 over 1, up 2 over 1. So it remains constant. Which unique point on this graph gives you the slope of the graph and the unit rate of the change in the snow level? Well, if I look at this one right here, it goes from 0 and up across. So this here of 2 inches per hour gives me my unit rate. And so my x value is 1, my y value is 2, so the point 1, 2 is my unique point that gives me both. We can use a table and a graph to find the unit rate and the slope that describes a real world's proportional relationship. And the constant of proportionality for a proportional relationship is the same as the slope. So remember that the constant and the slope can be the same if it is a proportional relationship. Every 3 seconds, 4 cubic feet of water pass over a dam. Draw a graph of the situation. And then we're going to find the unit rate of the proportional relationship. So what they did is they tracked in so many seconds how many cubic feet of water passed over the dam. So at 3 seconds, they figured that it was 4 cubic feet. At 3 seconds, 8 cubic feet had gone over. At 9 seconds, 12 cubic feet had gone over, and so forth. Then they took this information, because seconds is my x value and cubic feet is my y value, and they graphed them. So at 3, 4, there's a point, and at 6, 8, there's a point, and so forth. And then they wanted us to find the slope. And there's 2 ways we can do it. We could do rise over run, but in a graph like that, we have to be very careful, because if you notice, there's only 5 points before we have a 10. So that means that each unit up is going up by 2s. if I look across, these are also going by 2s, so 2, 4, 6, 8, 10. So when I'm counting my rise over run, I need to skip count by 2. So I'm going to start from this point, and I'm going to move to this point, and then I'm going to go up 2, 4, 6, 8. And then I'm going to run 2, 4, 6. So my slope, or my constant, is going to be 8 over 6, which simplifies to 4 over 3. So the unit over the dam and the slope of the graph are equal, and it is at 4/3 cubic feet per second. So cubic feet per second. Let's do your turn number 2. It says Thomas rides his bike at a steady rate of 2 miles every 10 minutes. So here's my miles, here's my minutes. We're going to find the unit rate of this proportional relationship. And there's a couple of different ways to do this. Well, first of all, if he doesn't go anywhere, it doesn't take him any time, does it? And then 2 miles every 10 minutes. So 10 minutes, 2 miles. And then I'm going to draw a line through those 2 points. We notice it goes through the origin, so we know this is a proportional relationship. 2 minutes or 10 minutes every 2 miles. We can also see that it is, in 5 minutes, you can go 1 mile. So it's going to be 5 miles per minute. Miles per minute. 2 miles 10 minutes, 5 miles every 1 minute. Okay. Using slope to compare unit rates, you can compare proportional relationships presented in 2 different ways. So this one we have an equation of y equals 2 and 75/100 x represents the rate in barrels per hour that oil is pumped from well A. The graph wait a minute.